Hi everyone, welcome to our talk on reversing bytecode into bounties. I'm Giuliana, this is Jamal. We're both security engineers at Atlassian. I work in security testing and Jamal works in product security, but he recently did like a 3-month stint in my team, which is where this talk comes from. And today we're going to teach you how to hack Atlassian marketplace plugins. So what's Atlassian? We make everyone's favorite products, Jira and Confluence. If you haven't heard of them, Confluence is like a collaborative Word that's online. It's documentation software. Jira is project management software. It helps with task tracking, originally for software teams, but now it's for everyone. For the old timers in the crowd, you've probably used our on-premise data center version. For fellow Zoomers, it's like the vintage cute stuff, and you've probably used our cloud offering instead. Our data center product, which we'll refer to as DC from here onwards, it's a version of Jira and Confluence that a lot of big enterprises will still use because it allows them full control of their data. It's very popular with them, and they run it themselves. They host it on a server. So that's the product that we're going to be talking about today. So you can download apps for both DC and cloud products on this Atlassian marketplace, but they're in very different formats. So the DC versions are Java apps that you download and then you run them alongside Jira and Confluence themselves to extend the existing functionality, which is kind of why we call them plugins versus apps. And they can be developed by anyone on the internet. It's a similar marketplace to like the App Store where you just go and download it, or Google Play. So that's the App Store. Why marketplace plugins? Well, because I mentioned before, they reside on the same host as the product. They share a database and they borrow functionality from Jira and Confluence. They're very well integrated, which comes with a lot of security risk. So a vulnerability in a plugin can very, very likely affect the host itself, the product that's running, and all the data that's inside of that product as well. So we've had a couple incidents actually where plugins have been compromised, which has led to the actual product itself, like Confluence being compromised, and then customers have come to us and been like, it's all your fault, even though we didn't write these plugins and we try to tell them to be responsible when they download, but it's still our fault. So we decided we need to do something about it to be like a responsible company. So we called this the Too Big to Fail project. A few months ago, we were tasked with pen testing our riskiest apps. And it was part of like a larger work around just improving the ecosystem as a whole. We started with the top 20, what we considered most risky DC plugins because of how much control they have over the apps. And we started with 20, and out of those 20 apps, we found 18 vulns, 13 of which were high and critical, which from our point of view, we're like, this is a win from the pen testing side, but it's not so great when you look at like, oh, these apps are probably even worse than maybe what we thought. There is public bounty programs, which is part of this talk, and we'll get to that at the end. But it's also a bit of a sign like, we only pen tested 20, we're going to get to more, but there's still plenty of bugs to be found out there and money to be made at the moment. So if we'd submitted these through our bounty program, we would have made at least $20,000, which is cool in 3 months. So then if we spent a whole year on this work, we would have made $80,000 for annual salaries. It's pretty good, but it's not going to get you this wonderful $2 million house in Sydney. But you'd probably need to spend about 25 years doing this bounty stuff and not spend a single dollar on anything else. And I'd also have to live with Jamal because we did it together. So, Anyway, back to hacking. So, what was our approach? First step is choosing a good target. Starting from the perspective of all the apps, how do you pick the best app to start with for testing? Then we'll show you how to decompile the marketplace app, and then do a code review of that code that you've just been able to decompile. and then the fun part, actually doing the pen testing, exploiting the apps. So how do we choose a target? Here's 2 examples of apps that we tested. Notice the high download count, and the app's functionalities are basically like RCE as a service. What could go wrong with that? Like, nothing. Yeah, the scopes, they're quite large. The impact of the security vulnerability in one of them is quite high. And yeah, that made them the perfect candidates for our testing process. Yeah, you can see the install count on the page when you load it up at the marketplace. And that is for data center. Don't ask me why the rating's out of 4. It bothers me very deeply, but that's just the way it is. But yeah, crucially, this app is also a part of the bug bounty program, which is important if you want to get paid. So yeah, this app that we've developed for this talk is called Spreadsheets for Jira. It doesn't exist, but it's a sample app that we can play around with and exploit vulnerabilities in so we can all learn together. So yeah, once you've found the app that you're happy with starting to test, you can get the jar file from that same page, download that, and I'll pass it to Jamal to explain what that is.
Awesome, thank you. So at this point, we've identified an app that we think looks interesting. It's potentially risky and it's got a high download count. We've then downloaded that jar file. Now, usually at Atlassian, when we're doing tests, we're doing Whitebox tests, so we have access to the source code. But unfortunately, these plugins are developed by third parties, so we're not privy to that source code. Now, when we were doing this project, we actually wanted to be able to do Whitebox testing, and this is why we came up with this process, figured out how to decompile them so we could go about our normal process. You might be wondering what a jar file is. Jar file stands for Java Archive. It's just a type of file that collects a number of Java classes, metadata, and different resources all into the one file, so that then the whole thing can be distributed as an application. So the jar file contains everything that the plugin needs to be able to run. Now, jar files are basically just zip files, and you can just run unzip on them. And by doing so, you'll extract all of that compressed information out. Now, occasionally, if you're going to go and do this at home after this, occasionally when you go and download a plugin, you'll get an OBR file instead of a jar file. Don't worry about it too much. You can also just unzip it and extract everything out, and it will just have a number of other jar files in there, and then you can decompile each of those jar files. So once you've unzipped the jar file, you'll find yourself with a number of class files, as well as all the other resources that you need. Now, a class file is basically just a binary file containing Java bytecode. And what we need to do is we need to convert that bytecode back into source code, into a format that we can read and understand, so we can go and analyze that code for vulnerabilities. If you open up the .class file in your text editor, it'll look something like this, which is not readable. There's a couple strings there. You can make out that it's Java, but that's about it. Some editors will allow you to actually show bytecode. I think I'm using cursor here. And it kind of makes it a little bit prettier, but I still can't read this. I don't know what it's doing, and I can't understand it. So using the decompiler will actually transform this back into a format that we can read. And after you've run the decompiler, you'll finally end up with some beautiful-looking source code that we're familiar with and that we can audit for vulnerabilities. Now, during our testing, we created a script to be able to decompile a plugin into its Java source code so that we could analyze it. And we're going to include this script in the resources at the end for you to all use. We actually found that using different decompilers, so we just used open source decompilers, we found that different decompilers actually resulted in slightly different source code, which also resulted in slightly different findings when we were running tooling against that source code. And so in the end, we ended up using 2 different decompilers in parallel so that we could kind of get a bit broader analysis. And so we used Procyon and CFR, and we'll have links to those at the end as well. After you've run your decompiler and you've actually decompiled the code, you'll end up with a directory that looks something like this. This is what our script will produce. So you've got 2 main things here. The first one is this top directory, which includes all the unzipped content from the jar. So it includes all the resources. You can see there's a velocity template, and there's also an Atlassian plugin.xml file. Giuliana is going to talk about that a little bit later. That's an important part of the plugin ecosystem for DC products. The other important directory here is the decompiled directory. This directory actually contains all of that decompiled source code. And here you can see that there's the Procyon and also the CFR directory. So you're going to have a complete decompilation of the app for each of those decompilers. Now, this is a very neat example, and we've created this for our demo. If you were decompiling a real plugin on the Atlassian Marketplace, it's going to be, inside that jar file is going to be all of the other libraries that it needs to be able to run things like Jackson or JSoup, JSON. And so this directory is going to become quite large, and decompiling quite a large plugin can actually be quite a time-consuming process. It can take quite a while to decompile it. All right, I'm going to hand back over to Giuliana to talk about code review.
Okay, so the next step we need to do is use all that code that we decompiled and analyze it for leads, for potential vulnerabilities. So SAST stands for Static Analysis Security Testing. They might take the form of scanners. They don't usually execute the code, but they just inspect it for dodgy patterns. It could be as simple as like string searching with grep, or more complicated, performing analysis on how vulnerable the code is as it's traced through the application. Some are a jack of all trades, like semgrep, which is the one we're going to be using for this talk. We like semgrep because it's community developed, it has custom rules, and in our case, we can pass it a specific Java rule set, which helps because we just decompiled Java code. So yeah, if we run that against our example plugin, here's a screenshot of one of the findings. You can see here it's got a couple elements to it. You've got the file path, so spreadsheet service implement.java. You've got the rule that the finding triggered on, so it looks like some sort of XXE, and then the actual vulnerable line of code, so the document builder factory dot new instance of the class. So we can take this as a starting point for something we want to investigate. But quick refresher on what is XXE. It stands for XML External Entity Injection. It's a bit of a mouthful. Here's what XML looks like. It's a pretty convenient way of storing data. Like, for instance, for our app, a user might want to export spreadsheet data from somewhere and then import it into Jira, and their XML might look like this, with a row and two cells inside of that row or columns. But you might also use XML to include files or fetch data inside of your XML, because why not? Like, what could go wrong? Yeah, so that's how you would do it here. You'd use an external entity, that's where the name comes from. But like, what if we tried to access local files that might hold sensitive data? For instance, Etsy password, right? A common file that people use to just see if they might be able to access something on the underlying server. You would do so like this and load that contents, and if that worked, you'd see something resembling a file like that. So yeah, if the XML processor doesn't explicitly block external entities, then we might be able to use this method to access sensitive files on the server. So let's go back to that semgrep finding and see how we might actually exploit this. So we'll start off with that spreadsheet service implement.java file, find where that is inside of the implementation directory, and go look at the code. So you can see that the document builder factory instance, it's been created with no security controls at all. They're commented out so we can visually see that here. You'd uncomment them if you want the code to be secure, but for us, like, we've intentionally made it vulnerable. So this is good for us. We can see that potentially if user input can reach here somehow, then this is going to be vulnerable. And it's sus, right? So let's go have a look. Where's this used? IntelliJ, you can right-click and see instances of a method. So we did that, and you can see that there's one instance of it somewhere else in all of this code, and we'll go take a look at that. It's inside of the REST directory, which is good. That's starting to make us think maybe this is an API endpoint, maybe user input's getting there. Open that up, and you can see a post endpoint being defined at the /process-xml endpoint. It takes in some XML, and it seems to be calling that vulnerable method that has the instance of the document builder factory. So this is good for us. We think we've got an entry point, but how do we actually know if this endpoint is exposed via the app and Jira? Well, that's where that Atlassian plugin.xml file comes in. This file is in every single DC app. It's like the manifest file for that app, and it contains a range of information about the app, not just the REST module, but dependencies and other things that might help you when you're inspecting them for security purposes. So we can go have a look in there, and we can see the REST module's been defined. The parts we care about is the path and the version, because that's going to form part of the larger path. And then also that the package is the same package that was used in the REST module that contains the vulnerable code. So theoretically, this endpoint should be accessible. We have a high confidence now that if we go to exploit this in the app, we should be able to trigger the XXE. So if we put this all together, we have a post endpoint. Jira REST is at the start of every Jira DC endpoint, so we have that there. And then the /spreadsheet /1.0 from that Atlassian plugin file, and the /process-xml from the actual REST module itself. So we're confident we've got an endpoint now, and we can start to exploit it. Before I jump into that POC, a couple other tips. In our testing, we came across a bunch of different annotations and things that are specific to Atlassian that helped us test these apps faster. For instance, we have these authorization annotations that we found some apps use these extensively, and it was just generally a good sign that like this app was pretty secure. Some apps didn't use them at all. So if they don't use them at all, you might be finding authorization vulnerabilities, broken access control, endpoints that are exposed that aren't meant to be, that sort of thing. So being able to just simply grep for these once you've decompiled the code is a good start. There's a lot of other annotations that are in our public docs, because remember, these apps are developed by third parties, so literally all the documentation's public. And we've put them in our resources that we'll share with you at the end of the slides as well. So yeah, they're pretty useful to look for when you're testing these apps. So yeah, finally we'll show you how to set up a testing environment and see whether this is actually vulnerable. Pass it back to Jamal for that.
Thank you. So at this point, we've identified an app that we want to test, downloaded its jar file, decompiled it, we've run some static analysis tools on it. We think we've found an endpoint that is vulnerable, and now we need to actually go and test that that endpoint is vulnerable so that we can go and submit our bounty report. So to do that, we're going to need to set up a testing environment. And the easiest way to do this with Jira and Confluence DC is to download the Atlassian SDK. The SDK will provide you a useful CLI tool that will download and run these two products for you so that you can go and upload that plugin and then test around with it. We're going to include a link to the SDK at the very end. The next thing you're going to want to do is go back to the marketplace listing for the plugin, because you're going to need to figure out what versions of Confluence and Jira the plugin is compatible with. So for our app, it's Jira Data Center 10 to 10.61. And once you've done that, you'll be able to use the CLI tool using the Atlas run standalone command, specify the product that you want to run and the version, and then that will go away. It will download about half the internet. It'll take a bit of time. It'll compile. Once it's finished running, you'll get this nice message saying localhost 2990/Jira is ready, and you have a version of Jira running on your host. When you go to access it, you can log in with the default credentials, admin, and now we need to upload our plugin. So to do that, we'll go to the top right, we'll hit Manage Apps, we'll upload our app, we'll identify our jar file on our computer, and we'll click Open. Jira will then go away and do the necessary things to install that plugin into the instance, and you'll find it listed at the very bottom of the list of user-installed apps. From here, the easiest way to actually start interacting with the plugin's functionality is to click this little Configure button, and doing that will take you directly to the functionality of the app. So for our demo plugin, which is also going to be in the resources at the end, we have this XML processor. We can click on that. That's going to take us to a page where we can upload an XML file and process it. And if we choose to upload a malicious XML file and process it, we'll get the contents of etc password. Now, alternatively, we can use the information that Giuliana found by finding this route, and we could create a curl request with our malicious XML. And this would result in the same outcome. We'd still get our etc password printed out to the screen. So this is an example of how we do Whitebox testing. Whitebox testing can help you find bugs faster. It enables you to use static analysis tools to generate leads and help you get moving a lot quicker. Now, it's not just Atlassian plugins that you can apply this, that you can apply this approach to. Anytime you're bug hunting and find a jar file, you can go through this same process to gain access to that source code. So I know what you're all thinking. This is very idealistic, right? There's some demo plugin, it's intentionally vulnerable to XXE, there's no controls in place at all to stop even the most basic of payloads. This wouldn't happen in the real world, right? Not with a production plugin installed by tens of thousands of users, right?
Anyway, let's see what we're doing to make this less bad. Okay, so we do app scanning for all of our cloud and DC apps uploaded to the marketplace itself. Things like secrets, hard-coded API keys, tokens, passwords that have just been left in the code. Vulnerabilities. In a similar way to this talk, we have an automated scanner that will decompile the code and try and scan it for like really critical things, high confidence things we have to report back to the app developers. Looking for vulnerabilities in packages used in CVEs and things like that. And then also just straight up malware, like malicious plugins that have been uploaded that might cause damage or try and extract information from customer instances when they go to install them. Or you could just move to the cloud. This is good for us because we make more money. Yeah. I mean, it's good for you too because these DC apps usually have cloud equivalents and they run in sandbox environments that Atlassian runs on our own infrastructure, and we have much more granular OAuth controls, and the apps themselves can do way less than what a straight-up plugin can do, which is like anything. So yeah, if you're on cloud and you're using apps, you can have a lot more confidence that the way they operate, they're not as broken, I guess. So yeah, you could always get off the old servers and move into the new age. Yeah, but this talk did promise bounties, right? It promised you guys money in exchange for the cool new skills. So at the moment, our marketplace bug bounty program's private, but you can sign up with this link. It's super easy. And it's actually better because at the moment there's not that many submissions and there's a lot of bugs to be found. So we actually see this as like quite a good opportunity for people in the room to use what the skills they have and kind of start off with a bounty program that's kind of not super intimidating and doesn't have a lot of like pro-crazy hackers, like, you know, submitting everything and anything they find. But yeah, we're looking to make them public in the new year sometime. So yeah, keep an eye out for that. You know, the bug bounty program for marketplace apps, it's not going to get you that like Sydney house that we showed you before, but it's a good start. It's a really good learning experience as well. And yeah, like I said, lots of vulnerabilities to be found. So we tested this process just to be sure. This is a sample app on our marketplace. And all we did is we just sent this like text to the link that we showed you, just saying, hey, can we join it? We've got some experience with like Java applications and testing them, and we got added the next day, and they didn't know we worked at Atlassian, so that was good. Thanks, Bug Crowd. Yeah, so pretty easy. But if you're sick of Atlassian by the end of this talk, I don't blame you. There's other companies that have Java software you can test. These are some of them. They're all blue for some reason. I don't know. It's cool. Blue's cool. But yeah, plenty of other companies you can go with public bounty programs and use the same process of decompiling Java apps and testing them. And this also works for our products themselves, which have higher bounty rewards. So if you're more experienced and you want to sort through much more jumbled code, then yeah, go for like Jira DC or Confluence DC, and you can test them too. Yeah, this QR code contains a link to a GitHub repository that will include all the resources that you need to get started testing. And if you've got any questions, Jamal and I will be around for the rest of the con, so come and say hi. Thanks, everyone.
Thank you.